Welcome back. In this outcome, we're going to crack the code of computer jargon, all those terms on a specification sheet, so you can read a review with confidence and compare two machines fairly. Let's start with why this even matters. When you go to buy a PC, the specification is packed with technical terms, the so-called jargon of computing, and understanding them lets you read a review and judge whether a machine is decent value. This outcome teaches you to make sense of a spec sheet and weigh two computers against each other. We'll decode the common terms first, then put them to work on two real PCs. Let's begin with the processor terms. The CPU is the chip that runs the whole show, with names like Intel Core i5 or AMD Ryzen 7. Gigahertz is the clock speed, telling you how many cycles run each second, so 3.5 gigahertz means 3.5 billion cycles a second, and higher is generally faster. Cores are independent processing units within one chip, and more cores let the machine handle more tasks at once. Now, the memory terms. RAM is the main memory, measured in gigabytes, and more of it means smoother multitasking when you've got lots open. You'll also see DDR4 or DDR5, which are just generations of RAM, with DDR5 being the newer, faster one. And cache is a very small, very fast pocket of memory right inside the CPU that keeps frequently used data close to hand to speed things along. Onto storage and graphics. For storage, you'll see SSD or HDD, and an SSD, especially an NVMe one, is far quicker than a mechanical hard drive, while capacity just tells you how much room there is, perhaps 512 gigabytes or a terabyte. For graphics, there's the GPU, where integrated means it's built into the processor, and dedicated means a separate, more powerful card, like an NVIDIA RTX 4060. Those two words, integrated and dedicated, make a real difference to what a machine can do. Let's finish the terms with the display and the ports. Resolution is the number of pixels on the screen, something like 1920 by 1080, which we call Full HD, and more pixels means a sharper picture. Refresh rate, measured in hertz, is how many times a second the screen redraws, so 60 hertz or a smoother 144 hertz. And ports are simply the connectors, USB, USB-C, HDMI, and Ethernet, for plugging in your devices and displays. Now let's put it together and read an actual spec sheet. A specification lists the CPU, RAM, storage, GPU, display, and ports in a fixed order, so you can read left to right, naming the component, then its key numbers, then its type or generation. Bigger numbers are usually better, but only when you compare, like DDR5 against DDR5, say. The processor, RAM, and storage together decide everyday speed, so don't be dazzled by one big number. A balanced machine matters more. Let's try interpreting a real review. It reads, an Intel Core i5 13400 with 10 cores up to 4.6 GHz, 16 GB of DDR4 RAM, a 512 GB NVMe SSD, and integrated Intel graphics. Unpacking that, the i5 is a solid mid-range processor. 10 cores at 4.6 GHz is plenty for office work and comfortable multitasking, and 16 GB is ample for browsing and light photo editing. The NVMe SSD is lovely and fast, though a touch small for big media libraries, and the integrated graphics are fine for video, but not for serious gaming. This slide is a quick jargon buster you can keep coming back to. It puts each term next to its plain meaning, so gigahertz is how fast each core cycles. A core is a separate worker inside the CPU, and RAM is the working memory for your open programs. An NVMe SSD is very fast flash storage. An integrated GPU is graphics built into the chip, while a dedicated one is a separate card. And 1080p or 4K simply describes how sharp the screen is. Plain words for scary terms, that's the whole idea. So, what actually decides how fast a computer feels? The CPU's cores and clock speed drive the raw processing power, and the RAM governs how smoothly you can multitask and run heavier applications. Fast storage, an NVMe SSD, loads the operating system and programs far quicker than an old hard drive, and a dedicated GPU transforms gaming and video editing. The real trick is that these parts work together, so genuine performance depends on the whole balance, not any single figure. Here are two real machines set side by side. An Office PC we'll call PCA, and a Creator PC we'll call PCB. PCA pairs an Intel Core i5 with 10 cores, 16 gigabytes of DDR4 and integrated graphics at a lower price. PCB steps up to an AMD Ryzen 7 with a higher top speed, 32 gigabytes of faster DDR5, twice the storage and a dedicated NVIDIA RTX 4060. Even at a glance, you can see these two are built for quite different buyers. Let's read those specs a little more closely. PCA actually has more cores, 10 against 8, which is handy for lots of light tasks running at once. But PCB counters with a higher top clock speed, faster DDR5 memory and twice as much of it, plus double the storage and, crucially, a dedicated graphics card. So on paper, PCB is clearly the stronger machine for demanding work, though as we'll see, stronger isn't always the same as better value. Let's weigh up just the processors, because it's a nice lesson in reading numbers together. PCA has 10 cores, but a lower top speed of 4.6 GHz, which is great for spreadsheets, browsing, and lots of small tasks at once. PCB has only 8 cores, but a higher top speed of 5.3 GHz and a newer design, so it's stronger on a heavy single task. Core count and clock speed really must be read together. Neither number alone tells the whole story. And for most office work, both are more than quick enough. Now, the other three components. On memory, PCB's 32 gigabytes of DDR5 comfortably beats PCA's 16 gigabytes of DDR4 for multitasking and large files. On storage, both use fast NVMe SSDs, but PCB gives you twice the capacity, a full terabyte against 512 gigabytes. And on graphics, PCB's dedicated RTX 4060 is in a different league from PCA's integrated graphics. And those three differences matter most for video editing, 3D work and gaming. So each machine has its own sweet spot. PCA is the better pick for office work, email and web browsing, for anyone on a tighter budget, and for lower power use and quieter running. PCB is the one for video editing, design and 3D work, for gaming thanks to that dedicated GPU, and for future-proofing with its extra memory and storage. Neither is simply better, they're built with different people in mind. Let's judge them by the task at hand. For office jobs and the web, both machines feel fast, so PCA is excellent value. For heavy multitasking and media editing, PCB pulls clearly ahead, and for proper 3D gaming, honestly only PCB is up to it. The better PC really does depend on what the buyer needs to do, and that's the judgment the assessment is after. Here's an idea that ties it all together, the bottleneck. A computer is only as fast as its slowest important part, so a speedy CPU hobbled by too little RAM or a slow hard drive will still feel sluggish. Pair a powerful graphics card with a weak processor and you waste the card's potential. So the real judgment is that a balanced specification usually beats one enormous number propped up by several weak ones. And when you compare PCs, look for balance across the CPU, RAM, storage and GPU. Let's practice once more, this time on a laptop review. It reads, an AMD Ryzen 5 with 6 cores up to 4.3 GHz, 8 GB of DDR5 RAM, a 256GB NVMe SSD, a 14-inch 1080p 60Hz screen, and integrated graphics. Reading that, the Ryzen 5 is a capable everyday mobile chip. 8GB is enough for browsing and office work, but tight for heavy multitasking. And the 256GB drive is fast but small, fine alongside cloud storage. Overall, it's a solid portable study laptop, rather than a machine for creative or gaming work. So let's reach a final judgment between our two desktops. For a student doing essays, browsing, and video calls, PCA is easily fast enough and cheaper, so it's the sensible choice. For a media student editing video and doing 3D design, PCB's extra memory, storage, and dedicated GPU genuinely justified the higher price. PCB is the stronger machine overall, but stronger isn't always better value. The right answer is to match the PC to the task and the budget. Let's gather up what we've learned. Computer specifications lean on Jargon, the CPU, gigahertz, cores, RAM, cache, SSD, and HDD, the GPU, resolution, and ports. And interpreting a review means translating those terms into what a machine can actually do. Performance comes from the CPU, RAM, storage, and GPU working together, never from one number alone. Our PCA, with its i5 16GB and integrated graphics, suits office work, while PCB, with a Ryzen 7 32GB and an RTX card, suits creative and gaming work. And a fair judgment always matches the spec to the task and the budget. So there we have it, the Jargon decoded, and two machines compared with a clear head. If you'd like to build on this, the reading listed here is a great place to go, with which, offering hands-on lab tests of real PCs and laptops, and the BCS glossary handy whenever a new term trips you up. BBC Bite Size and How to Geek remain friendly guides for firming up the fundamentals. Take a browse through the sources and follow whichever thread interests you most. And in our final outcome, we'll step back and look at what all this technology has meant for society.